In a real life, you have certain factors. So example, if I have a house and I have a year, so house space and year. So let's say year is 2023 and house space is 2000. And if I say the price, if this house is 500,000, right? Let's say our house is 2010 and space is, let's say 2000. What would be the house price? What would be house price? What do you guys think? Same square foot, 2000 here, 2000 here. Here 2023, here 2010. What would be the house price in 2010?
Cannot know. It's not predictable.
What if I ask you, will it be higher than 500,000 or lower?
We assume it would be lower, but
Okay. Why it is lower? You're right. Why it will be lower?
because inflation and different factors that raise the cost.
It's because or something else. This is the year which is house built versus this year. Space are same. They both have same space. But when it comes 2023, the house price is 500,000 and 2010, same space. Maybe this is considered as an old house and this is the new house, right? So if somebody asks, will that be 750 or it may be 300 range? What do you think? 300 range, right? And this is because, please pay attention, because you do know that newer the house, price goes up. Do you guys agree? But you also agree the older the house, price goes down. So the very old house, price goes down. So year of build, year the house build has, this is the factor, this is called factor. That factor is associated with the price factor and they have some relationship. So if year is new, price goes up. If year is old, price goes down. So there is a relationship, and this relationship we call regression. Space. If I have 1000 square foot house, then price will be, let's say, just example, 100,000. But if I have 10,000 square foot, what would be the price? 5,000? Or maybe 500,000. What do you think? So space, if space increase, the cost also increase. Do you guys agree? So in a real life, there are certain factor goes hand to hand, and there are certain factors are going across or opposite. So what I'm trying to say, if you have a factors which are going up and up, then that's called positive relations. If there are factors which one factor goes up and other factor goes down, then it's called negative relationship. So example, more I eat, less energetic I become. Makes sense or no? Or weight increase, then productivity decrease. Right? So some factors are opposite, some factors are positive side. Means example, more I educate, more salary I make. More experience I have, more salary I make, right? So that's positive. More people are less opportunity. So it's kind of opposite relationship. So this relationship has also type strong relationship and weak relationship. So strong relationship means if I know this factor, if I can predict this factor, then it's a strong relationship. But if I know this factor and I cannot predict this factor, then it's a weak relationship. So example, if I have bachelor degree, I make 100,000. If I have master degree, I make 150,000. Then I have PhD, how much I'll make? So obviously you can say it will be more than 150, so maybe 170. So this is a strong relationship. But if you say, I have no idea. Why? Because if I have bachelor's and let's say I make 90K and master, let's say I make 60K. Then I ask PhD. Then you say, I have no idea because it doesn't make sense. Bachelor to master, salary should go up, but it's going down. So you cannot predict here. This is called weak relationship. But here, as your education increase, your salaries increase, means it's a predictable relationship. So that is what we're going to study in a regression. So regression has a rule. First rule, that two factors should have relationship. Two factors should have a relationship. And the second, they should have a strong relationship. Okay, strong relationship. Now you say, but what is strong? So there is a concept called R square. There is a concept called R square, which is called regression, R square. In scientific way, if you try to do, you're going to go crazy because there is a special mathematic formula. But Excel make life easy. If this R square value closer to 1 means 0.9, 0.98, 0.95, then that's a strong relationship. But if this R square value is 0.7, 0.5, 0.2, then those are weaker relations. So first thing we need to see, do we have R square? And if R square is 0.9 or above, if yes, strong relationship. And if it is a strong relationship, then if I have some historical data, using historical data, I can easily predict the next value if I have a strong R square. Make sense? Any questions so far? Any questions? You will be using this thing, trust me. Okay, and very interesting exercise we will do today and next week also. So let's go to Excel and let's work together. So create a new tab, and add a two column X and Y. And let's add value 10, 100, 20, 200, 30, 300, 40, 400. Enter those values. Give me thumbs up once you add it. Good. I hope you added, right? Awesome. Good. Nice. Now, please understand, it's pretty clear that 10, 100, 20, 200, 30. Now, if I ask you, what would be the value for 45? What do you think? What would be the value for 45?
450.
450, right? Why? So this is a strong relationship. When this increase, and it is increasing proportional. 10 to 100 means 10 times. 20 to 100, 10 times. 30 to 10 times. So it's a predictable relationship. So far, so good. So how do we present here? So there are two factors, right? Two factors. Out of one factor is a driver, and one is a dependent or dependent or response factor. So example, when I increase this factor, I'm the driver factor, I can change. And when I change, I can see the reactions independent. So if I write a formula like this way, y equal to mx plus c, it means if I change the x, I'm changing y. I know x, and I want to find out value of y. So if I want to find out value of y, then that becomes dependent. That becomes a response variable. So example, if I know person educations, right? Bachelor's, master's, and I have his salary. But then I say PhD, what would be his salary? So I know these things. So that's my X factor. And I want to find out his salary. So that's my Y factor. So Y is response or dependent. X is the driver. Driver means it's change. So another example. Let's say I have two factor. One is the space, house space, and one is the house heating bill. Now I know house is 1,000 square foot, bill is let's say $30. House is 2,000, bill is let's say $45. House is 4,000, bill is $70. So now out of these two factor, house space and house bill, which one is a driver? Which one is driver?
House space.
Pretty clear. Why? Because if I change this, I can decide the bill. But if I know the bill, let's example 90, I will not know what is the house space. So house space I know, and depend on that I'm finding the bill. So this is my Y and this is my X. Another example. Let's say I have year and I have cells. 2000, you made 1 million. 2005, you made a 5 million. 2010, you made 12 million. And 2020, how much cells you will make? So which one is this is year and this is cells. Which one is the driver? Which one is a driver? Year, because this is driving the cells in amount. So you know this, but if you have this year, what would be the sales price? So anything you want to find out, if you want to find out this, that will become a dependent or response variable. And anything you already know it, it becomes your driver. Sounds good? And this formula is always like this: y equal to mx plus c. Y equal to mx plus c. Now what does that mean? So let's relax and pay attention. So the way it works is, when you draw the graph, this is the x-axis and this is the y-axis. If the line goes like in the middle, then you have perfect relations. Perfect relationship means m is 1 and c is 0. It means relationship is y equal to x. Means as you increase x, you know exactly what would be the y. Make sense? Perfect relationship like that. But sometimes it is possible that your line will go from this side. There is a relationship because you can see straight line means there is a relationship, but you are not going from origin. You're not going from origin. So this side is your error. This is your error. And this is your intercept. Intercept means you have error here. So this error is your C. So if line goes above or below, then there is a C. So this value is your C. And then the angle this line is, that's your M. M is nothing but slope. M is nothing but slope. Excel will calculate for us. So those who are scientists, data scientists, they do mathematics. We are going to do without mathematics through Excel with few clicks. And once we have M and C, we can easily predict Y. So let's assume M is 2 and C is, let's say, 100. So our formula will be Y equal to M is 2, so 2x plus 100. So now if X is, let's say, 45, then I put X here, multiply by 2 plus 100, then I can easily calculate Y. So our goal is to create this formula so we can calculate Y. Sounds good? So let's do a couple of exercises so you can easily understand this behavior. So now let's do the exercise. So I have X and Y, where X is the driver and Y is the dependent. So click on data analysis. So click on data analysis. Click on data analysis. And if you scroll down, there is a one thing called regression. Click on regression. So click on data analysis and click on regression. Okay. Now click on OK. So regression and then click on OK. And you will be getting dialog box like this. Oops. Yeah. Let me know if you are able to see dialog box like this. Give me thumbs up. Okay. Okay, nice. Now in this one, you can see how nicely it is giving Y range. We already know Y range. So select this as a Y range. So this one is your Y range. And then this one is your X range. Highlight and put it here. It's an X range. And make sure you check label because this label is checked because we are going to use this label. And we are going to create a new worksheets, right? And we'll see how it works. Okay. Also you check line plot, so you will see how it works. Line plot, right? So let's get started. So Y range, I click here and I highlighted that. So that's a Y range. So you can see here, I selected this and I click. After I do that, I click here. Make sure you click here. So you click here, your cursor will blink. Now you highlight this. Now click on label because you are having label here, and then click on line fit plot. So you label is here. This is going to create a new worksheets and line fit. Now if you do OK, it's a perfect relationship. You can see now there is a perfect relationship, means every time you can draw a line and it will go connecting all the dots. So that's a perfect relationship. And it is going from 0. So your C will be 0. C will be 0 means no error. And M will be 45. So if you draw this line, this will be 45 degree. So if it is a 45 degree, line is straight and it is going for 0, then you have perfect relationship. Perfect relationship means your R square will be 1 or closest to 1. Make sense? So a couple of things. C, which is you're going from 0, which is C is 0. Angle is 45 and R square is 1. If you have that, perfect relationship. So if you see here, if you expand this thing, it does say R square is 1. So if R square is 1 means regression is perfect relationship. if you see here, intercept, which is your C, is 0. And X, which is nothing but your M, is 10. So if I see the formula, Y equal to mx plus C. So what is M here? This is your M. Always this is M. So 10. X is X and C is 0. So now the formula is Y equal to 10x. So if Y equal to 10x, if that is the formula, then I go here, here, and if somebody give me 45, so I know Y equal to 10x, but X is 45. So if X is 45, then I will multiply that and I can get 450. Make sense? Because it's a perfect relationship. I can confidently predict. If somebody say, what about if my X is, let's say, 32? Very simple. Y equal to mx plus C, where C is 0, M is 10, M is 10, and X is 32. So now 32 times 10 will be 320. You will get that predictions. So that is the reason regression, if R square is 1, you get the best prediction. Any questions so far? Any questions with respect to how I got this? How R square came up? Don't worry about this. This is come up with a scientific way. Don't worry about this aspect right now. I'll cover. Intercept is nothing but C. C is 0 because you're going through origin. And M is the multiply factor. In your case is slope. So here your formula perspective, M is 10. X plus C, where M is 10, C is 0. So your formula is Y equal to 10x. Any questions you have so far? So far, any questions? Everyone is clear? Murthy say he's clear. What about others? Good. Awesome. Now, let's go back to the data. And I change the data. Let's say 12. And let's say 12 is this. And let's say this is 22. And let's say this is 32. Okay. I change the data. 12, 22, 32. Okay. I change the data. Now let's try it one more time. Data analysis, regression. Okay. Good news, it is selecting the data. If you want to change it, you can delete it and you can select your Y here, right? If you want to change this, select it, delete it, and you can create this as your X. Make sure your label is there. Make sure you're this, make sure you're this, and try to do OK. So if I do OK, now see the R square. R square value is 0.93. What does it mean? It is not a 1. It means there is an error. And you can see here, error is 15. And your M is here 12.33. Error is known as a C. So your formula is now Y equal to mx plus C. Because your value is still greater than 9.9, it means strong relationship. So I will take it. But because it's not 1, it's not a perfect relationship. So I have error. So C is 15 point. So I will add a 15.85. And M is 12.33. So 12.33 times X. Now X can be anything. So like example, if I say X is, let's say 40. So I said 12.33 times 40 plus 15.85 will be the value of Y. And this way I can predict Y. But no matter what I do, I will always have an error. Why? Because my R square is not 1. But rather than making a hunch decision, you are making data-driven decisions. These decisions will be still much better than hunch decision because you're getting all calculated through scientific way. So industry is always looking for regression. And good news, these data C value and M value comes from your data. So if your data is good quality data, and if you do a couple of times, and if you're getting better result, then your prediction will have a less error. There will be always error. Prediction always have error, but you can minimize the error. How do you minimize the error? Get a good data, X and Y. Get like a 10 years, maybe 15 years, maybe 20 years data. The more the data accurate your M and C. If your M and C value is accurate, then you can easily predict Y value. M and C is depend on your historical data. So if your historical data is wrong, then your value of M and C will be wrong. It means prediction will be wrong. But before you predict, always check what is the R square. If R square value is 0.5, don't predict. You will not be able to predict. But because it's a 0.93 above, I'm predicting. I know there will be error. But because I'm having good data, when I predict, I'll be closer to the actual value. Questions? Question, concerns, doubt. So far, so good. Give me thumbs up. So we'll do the next exercise. We are not done with regression. We are still doing regression, but we'll do a couple of more exercise. Okay, perfect. So now go back to your file which you downloaded. Remember you downloaded file. Double click on LR. LR is for linear regression. Double click on it. So when you double click on it, you will get the linear regression file. Now, these are different type of linear regressions we have. Okay. Let's start with the linear regression first one. So let's click on this one. And if it is protected, enable that so you can do well. Right. Now, please understand what is the exercise. This exercise is you have a square foot and you have energy bill. We want to find out what will be the energy bill for this space. So when we select, we don't select this number because we have to find it. Our data is up to this level. Okay. First exercise, I'll do it and I'll ask you questions, see how fast you do. Today, you all are kind of a little bit lighter and responsive. So I want to see how fast you can answer it. So let's go to data, click on data, then click on analysis, go to regression, do OK. And if you see something selected, just click it, delete. Click here and just delete it. Make sure you delete it so you won't have confusion. If it is selected, just delete it. Remember, first is the Y, and why you want to find it. So you will select the now highlight this thing and don't highlight the gray area. Okay. So see here, I click here first. Make sure you click here and select only this yellow portion. Okay. So I'm clicking here and selecting this portion. Then click here. Then make sure you click on the second item. Make sure you click here. After you click here, you select this item up to this. Make sure they are equal. So these data are equal with orange. So that's why you select up to this. Don't select the last value. Make sure your label selected, line fit selected. Please see here. This one is this item. That's your Y. And this one is this item. Make sure you understand this. It's pretty easy with Excel. The labels are selected here because you are selecting label here and line plot. And now say OK. So when you do OK, what is my R square here? What did R square you got? What is my R square now? Do I have strong relationship or weak relationship? If you can.
Strong relationship.
Very good. If you can.
0.987.
Very good. And what is my C value here? What is my C value? You can see the line is going here. So this is my C value, and C value is 35. Thank you. And what is my M value? this thing, right? So now I have a proper value C and M. So let's write it down. 35.26. Let's write it down. So my C value is 35.26. Sorry, my mistake. C value is 35.26. And my M value is 0.025. So my equation will be now mx plus C. So what is M here? M is 0.0225. X I have to find out, and then C, which is 35.26. So using this one, I'll go back to my linear regression. That is my tab. And now I'm going to use formula. So please follow me. I want to find out this item. So I'll say equals. I'm going to say equals. What is my M value? So M value is here. You can see here 0.025. So I'm going to take this thing equals, and I put it here, times I multiply this. Okay, times this plus C. What is the value of C? This one. And I put it here. So you can see here I got my M value multiplied by this one, and then I got my C. Now if I press enter, you can see nicely equals, right? This one multiply. So this one will multiply by my M value plus C. And if I press enter, I got 107. Did you guys got 107? Or what did you guys get? Got very close? This is the formula. Got it? So why don't you tell me 1150, what would be the value? Come on, go fast. Do the similar formula for 1150 and tell me what did you get? Okay, Eva got that. Wow, you guys are awesome. So I'll say I use this formula, I copy this formula, right? And I paste it here. Oops, sorry. And I paste it here. And rather than A8, I'm going to click here, and I get 61 point this. Do you think it's hard to predict now with regression? Say yes or no. Pretty easy. Do you agree? And this one will be more accurate. Why? Think about if you have good data, you will have good prediction. Why don't you try the next one? So next one is very interesting. Please understand. You have service calls and you have cost. So if you get service calls, then this is the cost. So why don't you tell me what would be the value for this many calls, right? I'll give you a few minutes. See if you guys quickly get M and C and get me the value. So that's a tab, linear regression 2. Click here and get me the value for this call. See how fast you do it. Go and quickly get it. Let's see who is finding first and who is finding right. Good, good, good. Wow, Eva got it. Awesome. That's others are able to do it. If two people have the same answer, then the answer is correct. So let's see who else will get the correct answer. Eva, you did super duper fast. Seems like you know regression very well now. Nice, nice. Let's see who is coming closer. Okay, very good. Kenwa also did it. Very nice. Let me try myself just to make sure how easy it is. So data analysis, click on that, regression. Okay. If it is selected, just delete that. So don't confuse yourself. Just select and delete. Then click on that. Select the orange portion only. Then click on X and click on the relevant process. Don't select 1140. Don't select that. Then label is already there. Everything is there. Just okay. Check first of all R square. Is it 0.95 above? Yes, so it's good. And check your C and M. So you have C and M. It's always a good idea to take a notes of C and M. So I normally put it in Notepad. So I know my C and M. So C and M is here. So first is the C and second is the M. Then I go back to my linear regression 2 and then I put a formula. So I'll say equals to M. So C and M. So M is here. So I'll take the M times X, which is this one, plus C. And we do have C here. And if I press enter, this is what I got. And it seems like you got the similar thing. Not bad. I'm impressed. I'm impressed if you are able to do that, right? Pretty cool. Awesome. Our answer might have a little bit variation, but that's completely fine because maybe decimal points and all, just we are ignoring because when we are getting this value, sometimes I use full decimal value, and some of you might be using less decimal value. So that there will be last digit might be plus or minus, but that's okay. That's perfectly fine. Yeah. Awesome. Now let's go to the next one. Click on that, click on this, and answer one simple question. This exercise quite easy. That click on this one and answer price of Coke and case sold. Do they have a relationship? Yes or no? Try. Yes or no? You just need to tell this relationship exists, yes or no.
Yes.
So anyone else? Yes, no? Oh. So now koi say, hey, no. Oh, Eva say yes. Oh my God. Now we have tie. Yes, no, yes, no, yes, no. Oh. So this is very interesting now. Mike says thumbs down. So no, big no. So now check it out. Data analysis, regression, I'm deleting this thing. I'm deleting this. Simple, easy, powerful. So here I select case sold and I select the price of Coke. And when I do OK, I look for R square. And R square say that this is 0.2, means no relationship. You will see that they are not even going, the data is not even going from origin, rather than it's going like this. So this is no relationship. So if R square is not 0.95 or above, then relationship is very, very poor. This is no relationship. If you have zero point 0.8, if you have 0.7, then I'll say some relationship, some, but still weaker. 0.95 above or closer to 1 is a strong relationship. The stronger the relationship, the better the predictions we can make, right? In a statistical language, listen carefully. In a statistical language, we are saying based on R squared, our model means y equal to mx plus c, only predict 0.23 means 23% time x value can predict the y. Only 23% time. What does it mean? 77 times we are wrong. That's pretty bad. So if this value is, let's say, 0.95, so how do you speak up in a statistical language? So this is what you say. Based on R square value, based on R square value, 95% time, 95% time, knowing X value, we can predict Y value. It means 95% time you will be accurate. Pretty good, right? Yes or no? Now, I want to show you multilinear regression. So far, we are doing one, we have one regression. So the formula is like this, y equal to mx plus c, because this is your x and this is your y. But what if you have three factor? Factor A, factor B, and factor C, right? So this can be x1, this can be x2, and this can be y. In that case, how you write? Y equal to, in that case, how you write? Y equal to m1 x1 plus m2 x2. You write like this, plus c. So what is m1? What is m2? Sometimes you may have c1 plus c2 also. All those things our Excel will calculate for us. When you have multiple factors, for example, education and experience helps you to drive or calculate salary. So more educations you have or more experience you have, you can get salary. If you have both higher education and higher experience, you get a higher salary. So there are two factors can help you to predict the salary. So that's called multi-variable regressions or multi-variable regression. How it works? Let me show you. One I'll show you because you will do the similar thing in homework. So here, in this case, you have two things, quantity sold, you have price, and you have advertisement. So now you have X1 here, X2 here, and you want to know. So if I keep price and if I say how much advertise I do, can I predict how many item I'm going to sell? Because if I lower the price, I might be able to sell more. And if I do more advertisement, I'll be able to sell more. So number of sell is depend on advertisement and it also depend on the price. So how does these two factor help you to determine the number of sell? So there is a concept called multi-regression. So rather than looking R square, rather than looking R square, because R square works on one-to-one factor. But because you have two factor, you have to consider multi-linear regression factor, which is called multi R square. So multi-regression R square is again 0.95 or above, then you can predict confidently. Otherwise, don't predict it. So let's see here. Let's work together. So why don't you, oops, what happened with this guy? Yeah. Why don't you start here? So click on the regression here and click on data analysis, regression, delete this thing, delete this thing. Now you can see here, I have two factor, input X and input Y. So I'm going to select both of them, right? So check it out. Here, I'm going to say input X. I'm going to select both of them like this. So I selected both of them. Okay. So see here, I selected both of them. And in Y, I selected this. So please understand, I selected X, I selected both of them. And I selected Y just like that. Rest of thing, everything is there. And if I do OK, it is going to error out. Why it is going to error out? Because in a single variable, I'm trying to do multi-regate. So it's not going to work this way. It's not going to work this way because it has only X1 and Y1. So I'll say, okay, now I'm going to cancel this. I'm going to cancel this. And if you scroll down, there should be a multi-regression. Did you see that? One second. Do you see two factor with the applications?
Maybe we can use regression still, but
Yeah,
don't highlight the first
yeah.
row.
Yeah, that's what I will be doing. So I just want to say that. So first of all, this is my Y. So if but I have label, but that's fine. If I remove this part, let me remove the label. And I'm going to remove that. Okay. So input Y. So I'm in input Y. I'm going to select this data. And then input X, I'm going to select both of them. Okay. The problem is, one second, why am I not getting that options? Let me check it. If I, because then it will not know which one is X1 and X2. That's my problem. So here, so it would be challenging here. So you can see to get the data. So you can see here, I got the data X1, Y1. So it got the X2 variables, intercept, it got it, and it got the thing. This worked. This will work. Okay. Let's try this one. Let's do one more time. So at least you guys can do that. So let's go to data analysis one more time. Regression. Okay. And I'm going to delete this thing. I'm delete this thing. Okay. First, input Y, I'm going to select only the value. Only the value. Sorry, my mistake here. It's supposed to be click here. First click on Y, select the orange space like that. So that's your Y. Then click on X and select these two columns like this. So you can see here, appropriate value. So this is this value. And this one is actually selections of entire this two column. If you have three column, you would have selected like that way. Don't select label, otherwise you get an error. Line fit and this. Now do OK. So when you do OK, you will see that now there is a concept called multi multi-regression R-square. So you can see that multi-regression R-square is 0.98. It means it's very close to 1, means strong relationship. Now you can see C is there, and you have here x1, which is M1, and x2, which is M2. So now the formula will be y equal to M1, which is here, minus 835.722 x1 plus 0.592 x2 plus C, which is here 8536. So now if you know x1 and x2, you can plug here and you can get the y value. Make sense? Any questions so far? So let's say I get this value and I copy this value. And let's say my manager say that, hey, we are going to do advertisement. So I go here and say, we are going to give unit price 4.5. And we're going to do advertisement $1,500. Tell me how many units we're going to sell. So I said, don't worry about it. I'm going to tell you exactly. So I'll say equals M1. So M1 is this one. So I pick the M1 value times X1, which is this one, plus M2, which is this value, times, which is this value, plus C, which is this value. So let's understand what we are doing. So this is my M1, this is my X1, plus this is my M2, this is my X2, and this is my C. So if I press enter, I get this. So we are saying that if you do price 4.5 and you do advertisement, you're going to sell this. So let's do litmus check. Litmus test check. So if I say 4, you are selling this thing, but that time you do advertise less. So if you do advertise more compared to 4.5, you are selling more, which is good. What about 5? So in 5, if you do less advertisement, you were able to sell this. But because the price is less and you are doing advertise more, you are selling more, which is good. So this is the litmus test. So if you do 5 and you do price advertisement more, you are able to sell more. So it means advertise does help. Advertise does help. Not price only help, but advertise also help, and you are able to predict it here. Any questions so far? Any question, concerns, doubt?